Today we are going to learn about how to calculate trainable number of parameters in both in LSTMs and GRUs. But before that, we will try to understand how to interpret the shape. Whenever we feed the data into LSTM or GRU architecture, we make sure to reshape our data, and we often reshape it to this value. Let me write it. So for suppose if you have ever seen, the exchange shape is like, um, for this example I am making exchange shape like this. So it's 553. Now what does these numbers represent? So 5 here represent first 5. This 5 represents that how many sequences are there. Okay, and in those sequences how many words do I have? Okay, one sequence contains how many words per sequence. That is timestamps, or you can basically call it as timestamps, or how many times the RNN will unfold itself. And the 3 represents the number of features. Okay, 3 represents the number of features. How one word or one particular thing is represented by how much, or what is the shape of the vector that is representing the word or a certain number. We usually represent words only. We represent numbers through numbers, but whenever we are trying to do the word embedding like this, so let me explain. I have these 5 sentences. I am ABC, I am XYZ, I am from PQRS, and I am a teacher assistant. For example, these are 5 sentences, and then I want to feed them into LSTM or GRU. So I need to do the text processing and stuff, or word embedding. So what I did basically is I calculated first of all how many words are there, or for example, I'm trying to represent this I am ABC like this. So there are total, first of all, how many sequences are there? There are 5 sequences, and in each sequences, how many times will the RNN unfold? This is for, it will fold for I once, then it will unfold for M, and then it will unfold for ABC, and then it has to unfold 2 more times just for the sake of having input shape consistency. So 0 0 zeros will be processed after that, and the obviously anything multiplied by 0 is always 0. So this sequence will unfold 5 times. So unfolding, people often call it as timestamps. So you can whatever you can pick the name for yourself, it doesn't matter much. And then 3 represents in each timestamp how many features are there. So in each timestamps there are 3 features, 1 2 3, here also 3, and here also 3. So after understanding how the exchange shape works, let's try to understand how LSTM works with the help of one example. So this is, I already did it, but let me just erase it. First of all, we will try to do it with intuition, and then we will try to learn the formula. So to feed the data into LSTM architecture, we often write it as input shape. Okay, this is our input shape. So my RNN will unfold 3 times. It will unfold 3 times, and number of features are 1. Okay, number of features are 1. And how many nodes are there in LSTM? There are 5 nodes. Now can you see these 5 gates in RNN? Sorry, these 4 gates in RNN, or 4 boxes to be really precise. There are 4 boxes in this LSTM structure. Yep. Now let me minimize it again, and let's try to understand what is going on with within these boxes. So let me draw this first box, the second box, third. So these boxes contain our nodes which try to establish connection within the things. Now we have the input box also. Now, as the number of features says it has only one feature, so we are going to make only one node for input box. So there is going to be, okay, number of features decide the number of nodes in input box is equal to number of nodes for input box. And here I have defined 5 number of nodes for LSTM, so I'll make 5 nodes here. 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5 here as well. So all these 4 boxes contains equal number of nodes to have the better or same dimensions or same shape consistency. Okay, now we'll first make a connection of input box with the LSTM node. First LSTM box with the input box. So in trying to establish this connection, we had to take the help of 5 lines. Therefore, the input box to LSTM box connection took 5 lines. So there are 5 weights. And now what is the speciality of RNN? It is that these nodes are connected with themselves as well. So that is what differs them from ANN or CNN, because here the nodes are interconnected as well. Okay, this node is connected with this node. This node first of all is connected with itself, then it is connected with this node, then it is connected with this node, then it is connected with this node, then it is connected with this node. Or you can just redraw it like this, but this the drawing that I'm going to do it in just few minutes is mostly not used because then it creates some confusion. Okay, so you can say they are interconnected to each other like this. You can just make one more copy of it for your reference, for your own understanding. Otherwise things don't work like this in real life. They just try to make connections like this only. Okay, so we have something called LSTM to LSTM connection here. Okay, the vocabulary that I'm using here is not standard. Okay, so I'm just trying to use the vocabulary for my own understanding or for my own preparation. So LSTM to LSTM connection will have 5 nodes will be connected with 5 nodes that is within themselves. So it is going to be 5 times 5, 125. And then these nodes only will have biases. So one node will have bias. Each node will have its own bias. This one will also, so it will have 5 bias. So bias in LSTM is 5 again. Now if we add all of them together, it is going to be 25. 5 times 5 is 25, my bad. So 25 plus 5 plus 5 is equal to 35. And now here we have 35 weights and biases. Here we'll also have 35 weights and biases. Here we will also have 35 weights and biases. Here we'll also have 35 weights and biases, because they are all same number of connections. First of all, there will be a connection with input box to LSTM box, and then there will be within connection of LSTM box with LSTM nodes itself. Okay, LSTM nodes with LSTM nodes connection, and then we will have biases, each bias. So we'll have total of 35 times 4, because there are 4 boxes here. So we'll have, just a minute, yeah, 35 times 4 number of trainable parameters. So it will be total how many trainable parameters for this LSTM architecture, there will be 140 parameters, or for this LSTM layer there will be 140 weights and biases, total trainable parameter. Now let's try to do it with the help of formula. Let me make the box again. There are also five nodes within each boxes. So here first number represents how many boxes are there. 1 2 3 4 boxes are there. And then in number of features in input node, number of features times LSTM node. So this is making the first connection between input and the LSTM box. And then we have LSTM nodes connecting within themselves times LSTM nodes. And then we have LSTM biases. So even though you sometimes forgot the formula in exam, but you can just draw it and try to calculate accordingly. So I really hope that it is helpful for you. Now let's try to calculate using this. It is going to come the same. It is going to be the same only, but let's just try to calculate. So it's 4. Number of features is 1 times LSTM nodes is how many? 5. Plus we have the LSTM nodes connection with the LSTM nodes. 5 times 5 is like this. Plus now we have LSTM biases, which is equal to 5, because number of nodes is equal to, each node will have its own bias. So that is why 5. Calculating everything, we'll get 140. Okay. So now let's try to do it with one more question. I already calculated here, but no worries, we'll do it again. So first of all, let's talk about the extrain dot shape. Extrain dot shape is 560, 60. That means we have 500 sequences in our data, and each sequence will unfold 60 times, and there will be 6 features to represent each timestamp. Oh, I meant to erase it. So this is input shape. So our input shape, even though it doesn't matter how many sequences we have, how many timestamps we have, whenever we try to feed the data in the LSTM structure, we feed it in this way. We write the input shape. So input shape, we reduce it from here, that is 60, 6. But our trainable parameters or features, trainable parameters are dependent upon this input, this in features. So 6 features are there. That is only thing which is very important. And we have 16 LSTM nodes. You can do it by box method, or you can, if you have memorized the formula, that is well and good. So like this, there are total 16 nodes. Again in this box as well, in this box as well, 16 nodes. In this box as well, there are 16 nodes. And then we have input box, which has 6 nodes. Let's just calculate for one box, and then we will generalize it for the other 3. So making the connection of making the input box and LSTM box connection, we will have 6 times 16. These number of lines will establish the connection between input box and the LSTM nodes. It will be 16 times 6 is 96, right? Yep. And then we'll have LSTM to LSTM nodes connection. It will be 16 times 16, which is, I believe, 256. And then we'll have how many biases? Okay, LSTM nodes to LSTM nodes connection. Here we'll have input to LSTM connection, and then we have bias is equal to 16. If you add all of it together, you will get, let me do the use the calculator. It will be equal to 368. Okay, 368 but for one box. So 368 for this box, 368 for this box, then 368 for this box, and then 368 for this box. So we'll just multiply it with 4, and then we'll get the answer to be 11472. So there are total 1472 trainable parameters for this set of question value. Okay, I'll give you the questions in the at the end of the video as well for you to practice. Make sure you write in the comment box below what is your answer, and then I'll try to, after 2 to 3 days, I'll try to write the answers as well. Yes, now let's try to understand the GRU stuff. So LSTM is bit like GRUs. Actually, it is a better version of sorry. GRU is a bit like LSTM, and it actually GRU is a better feature, or is a better function, better than LSTM. So here you can see there are only 3 boxes. It's going to be the same story again, but just the only difference is it's going to be that it will have 3 boxes. So one box here, one box here, and one box in the GRU layer. Now we have the input box. In GRU layer, how many nodes are there? 5. Let's draw 1 2 3 4 5. Here also 1 2 3 4 5. Here also 1 2 3 4 5. Here if we'll talk about 3 comma 1 shape, what does it represent? It represents that this RNN layer will unfold itself 3 times, and the number of features that is we are examining or doing the calculation on is only 1. So there is only one input feature here. Now first of all, let's make the connection of input to GRU box. In that we will have to draw 5 lines in order to do that. So GRU to input connection, we will have 5 weights, and then GRU to GRU connection, as I told you, these nodes will connect with itself also. First of all with itself, then with the others. So yeah, the connection, they will be interconnected with each other. First of all it will connect with itself, then with others. So it is going to have 5 times 5, which is equal to 25 weights. And then how many biases are there? Biases will be equal to the number of nodes in the GRU box. So it is bias in GRU, it is equal to 5 biases. If we add all of them together, it is going to be 35. Now 35 for each box, 35 for this box, 35 for this box as well, because it's going to have the same number of connections, same number of GRU to input connection, same number of GRU to GRU connection, and same number of bias to GRU connection. Okay, bias in GRU actually. So 35 here as well. So we'll directly multiply it by 3. So it is 105 weights and biases for this GRU layer. We will have 105 trainable parameters. Let's try to do it with the help of let's try to do it with the help of what I was going to say, formula. So its formula is also same. It is that we are going to First of all, write 3 because 3 represents how many boxes are there. We have one box, second box, and third box. And then we will have the number of features in input, number of features in input multiplied with GRU nodes. Then we are going to have GRU nodes connecting with itself only. So GRU nodes times GRU nodes. And then we are going to add the biases as well. So each node will have one bias. So here a bias will be how much? Bias is GRU nodes only. Number of GRU nodes. So let's try to do the same thing with the formula again. So number of input features is 1 times GRU nodes is 5. Then now making GRU nodes connecting with itself is 5 times 5s. And then how many biases are there? 5 biases are there. So it's going to be, what was the answer earlier? I believe 105, right? So there are total number of 105 trainable parameters in this GRU layer. Let's do one more example and then I'll give you some homework for the to practice. I already did the calculation, but let's just erase it. Oh, answer is already there. No worries, we'll do it by ourselves. So what is the, first of all, what is the meaning of this shape here? Is that we have 50 sequences in our in our data. We have 50 sequences in our data, and each sequence will unfold itself 20 times, and in that time, in one timestamp we have 4 features. And how many GRU nodes do we have? We have 32 GRU nodes. Let's make the diagram real quickly. So we know there are 3 boxes in GRU nodes. So there are 32 nodes here, 32 nodes here, and 32 nodes here. For the input, we have only 4 nodes. So number of features decide the nodes. Now, while making connections, we know the input to GRU box connection will be 32 times 4. Then GRU to GRU connection will be 32 times 32. And then number of bias in GRU will be equal to the number of nodes in GRU, which is equal to 32. Let's try to do it real quickly. I do have a calculator with me. Here we'll have 1024 and then here we'll have 32. Let's add all of them together. So it's 1184. So 1184 for this box. 1184 for this box, 1184 for this box, 1184 for this box. So basically we'll just multiply it by 3, which came out to be 3552. Total number of trainable parameters for this GRU layer will be 3552. Now, if there is any doubt, please do let me know in the comment box down below. We have some questions for you. Here it is, the first question, GRU layer, LSTM. Make sure you write down the answers and I'll check it for you or you can check it by yourself. You can also ask chat gpt obviously. So here is the GRU question. Here again we have the GRU question. So let's meet in the next video. Bye.